right. Here we go. Okay, so we are on notes part 2 for 2.13. And the very first problem says, find the inverse of this function. So we know how to do that. We know how to find an inverse. What's the first step to finding an inverse? Switch your variables. Switch your variables. So the original problem is y equals, so I'm going to change it to this. All right, is that okay with everybody? My variables are switched. Now, I can do whatever I need to do to get y by itself, right? So what do you think might be a good way to begin? Add 15. Now what? Divide by 3. So I'm going to make that 1/3 x plus 5. You certainly could leave that as x plus 15 over 3 if you wanted to. It makes 0 difference. So whatever you're most comfortable with. Now we have a problem because we are solving for y. And y is an exponent, and there's no way I'm going to get a common base here. So the only way to solve for that y is to use logarithms, right? And since that's a 2, I'm going to do base 2 logarithms. So I'm going to take my base 2 logarithm on both sides. Now remember, my goal here is not to type this in on my calculator. If I were going to type it in on my calculator, I probably wouldn't be using base 2. But my goal is to find the inverse. So, this side stays exactly as it is. Tell me what happens on the other side of that equation though. What happens over here? That's just y plus 4. That's the beauty of using the log base 2, because the log base 2 of 2 is 1. Okay. Now all I have to do is subtract 4. So my inverse is log base 2, 1/3 x plus 5 minus 4. I'll use correct notation, F inverse, or was it F to start with? Yep, F inverse, and that's it. What is the inverse of an exponential? A logarithm. Yep, they're inverses. All right, let's do the same exact thing, but this time we're going to start with a logarithm in example 2. So x equals -3 log base 5 x minus 4 plus 6. No y. Now I already switched my variables because I'm finding an inverse. Is that okay with everybody? Why, yes indeed, because that's always the first step, right? Switch your variables. You okay? Yep. All right, so what do you think we ought to do now? Our job is to solve for that y. So what should we do you think? Subtract 6. Divide by -3. And again, I'm going to split it. You don't have to. You can put the whole thing over -3. Well, no. Then I would have kind of a double logarithm over here. And I'm not actually even sure what I would do with that. It would be legit. I mean, there wouldn't be an error in doing that. But I already have a logarithm, Julia. I need to get rid of this logarithm. So rather than stick another one in, let's think about how do we undo a logarithm? How do I get rid of that?
If you like log roll and have 5.
Exactly. I'm gonna log roll this. So this is gonna be 5 to the negative 1/3 x plus 2 power equals y minus 4. 5 to this power equals y minus 4. Now, it's not pleasant, but the original wasn't pleasant either. I mean, so we're not really expecting something beautiful to come out of this. My inverse is going to equal 5 to the negative 1/3 x plus 2 plus 4. And again, we started with a logarithm, but we know that the inverse of a logarithm is going to be an exponential. Cool. All right, let's look at example 3. Let h and k, for what values of x does k of x equal 1? Okay, so keep in mind, k is the inverse of h. What do you think? Raina?
Would that be whenever x is 1 and the h of x?
Exactly. So Raina says, let's go ahead and find h of 1. Let's just plug 1 into h. So what do we get if we do that? If we plug 1 into h, we get 7. Now, without looking at any equation or anything, doesn't that automatically mean that h inverse of 7 is 1? And h inverse, they called k. And if we want k to equal 1, then doesn't x have to be 7? Very good, Raina. Very good. Kids who aren't on top of things like you are going to try to find the equation of the inverse and mess all around. You don't need to do any of that. You did it exactly right. Very, very good. Remember, this relationship is the key. All right. All right, now we're going to solve some logarithmic inequalities. This is an inequality. We want the log of x squared minus 4x plus 7 minus the log of x plus 3 to be bigger than 0. Okay, now there are a couple ways we can do this. As always, there's always lots of ways you can do it. I'm going to go ahead and add this guy to the other side. Is that okay with everybody if I just do that? And then if this were an equation, what would I do at this point? If this were an equals problem,
Get rid of the log.
I just get rid of the logs and solve the equation. Well, guess what? We can solve the inequality. Before we do that, though, I need to stop and remember that logarithms have domain issues. And some of you are really struggling with this in the homework. Logarithms have domain issues by their very nature. The equation, or the picture of the logarithmic function is this. What is the domain of a logarithm? X must be positive. So in other words, whatever you are logging has to be positive. So this, before I even start solving, this has to be positive and this has to be positive. Okay? Now this one's easy. If that has to be positive, then x has to be bigger than -3. So whatever else happens, I'm gonna drop these logarithms, I'm gonna solve this equation, whatever else happens, that has to, that right there is first and foremost. Now, this has to be positive. Well, I don't know, that doesn't factor, does it? All right, I'm gonna go ahead and do the quadratic formula and see if I can figure out what's going on. X equals negative b plus or minus the square root of b squared minus 4. What's happening here? It's imaginary, right? It's imaginary, has no place in our conversation. That means, guys, this is a parabola, correct? It's a parabola opening up. I'm looking at just this quadratic. It has imaginary roots. Doesn't it look something like this? I mean, I don't know exactly what it looks like, but doesn't it have to behave like that? Which means it's always positive. So this one, we're lucky, is always positive, so I don't need to worry about it. All I need to worry about so far is this. Okay, so x squared minus 4x plus 7 has to be bigger than x plus 3. So x squared minus 5x plus 4 has to be bigger than 0. What am I going to do with that? Help! What do I do?
Factor.
F factors. Straight out of unit 1, it's a polynomial inequality. We draw our number line, do a sign chart. Got dots at 1 and 4. Pick a number over here, like 0. That would be negative, negative. Does that work? Yeah, sure does. So this is part of my answer. All right, pick a number in here like 2, negative, positive. Does that work? Nope. Pick a number over here like 5, positive, positive. Does that work? Yep. Now be careful. Remember this right here? So actually on the number line, I have my -3 out here. And while all this is shaded as a solution to this, I really can only count this part of it, because whatever else happens in this problem, x has to be bigger than -3. So my answer is -3 to 1 and 4 moving. Alrighty, there's some good review in that problem too. Alright, anybody stuck on anything there? Alright, next one, here we go. What's this one say? Looks like the same thing, kind of. It says g of x has to be less than h of x. So ln x squared plus x minus 5 has to be less than ln x plus 4. Yeah, g less than h. Now, it is so tempting to jump in and solve this. are going to solve that, and I don't care, you can do it first if you want, but what you cannot forget is that whatever happens here, this has to be positive, and this has to be positive. So before we even start, I would suggest we figure out what's going on here, but it doesn't matter. All three of these have to be in your answer, so the order you do it really doesn't matter. Okay, so I like this one. This one's easy. What that tells me is, on my number line, whatever else I end up putting on there, I have to be this way. All right, that does not factor, does it? So let's use the quadratic formula. Getting depressed. Is this what you guys are getting? I mean, did I make a mistake? I hope. Is that what you got? Alright, well, I gotta figure out where I need this to be positive. So I gotta figure out where this thing's gonna be positive. So, I'm gonna go ahead and get decimals for those guys. So I know where to put them on my number line. This is negative 2.79. And this is 1.79. All right, so I gotta figure out where to shade this. So let's put in negative 3. Negative 3 would give me 9 minus 3 minus 5. That's positive. So this works. 0 gives me a negative 5, so that doesn't work. And 2 gives me 4 plus 2 minus 5, which is positive, so that works. I'm going to go ahead and do that one on my number line. Here's negative 2.79, and here's 1.79. So far, I've got my black requirement from here, I got my pink requirement from here, and now I have to do this requirement. So what does this one say? Is that right? One more time. Got 3 and negative 3. Okay, so let's put in a negative 4. That does not work. How about a 0? That does work. And a 4. So my green requirement is negative 3 to 3. unless I made a mistake. Is anybody else doing that besides, I mean, is anybody else really doing it or just copying down mine? Everybody doing it? Did I make a mistake? Is it okay? Looks good? Okay. So what is the final answer? It must meet all three requirements, black, pink, and green. So what is black, pink, and green? Would you say right here? And right here? So what's the answer? Finally, after all of that, what's the answer? Oh, -3 to -2.79, unless you want to be exact, and then it would be -1 minus root 21 over 2. That was our -2.79 number. Or -1 plus root 21 over 2. I hear rumbling. Do I have a mistake, guys?
It's supposed to be -1 so to under your answer. -3.
Oh, yeah. Thank you. Okay, that's a lot. Right? That's a lot. Bunch of arithmetic. What you really just have to come away knowing that when you're solving a logarithmic equation, you must make sure that whatever you are logging is positive. That has to be part of the problem. Okay. All right, last one. What are all the values of x for which k is less than or equal to -31? So this is another inequality, but it's an exponential this time. All right, thoughts? You guys, you must have a thought. You have to have a thought on how to do this problem. Subtract 1. You're solving an equation, guys. Don't you want to get rid of that 1? And what else do you want to get rid of? Divide that -4 out of there. And be careful, since it's negative, we need to flip the sign, right? All those second grade rules haven't changed, right? What's special about 8? It's 2 cubed. So, does it make sense to you that x minus 3 has to be bigger than or equal to 3 in order to make this bigger than that? So the answer to the question is? And somebody might say, wait, Ms. Ford, wait, what about all that domain stuff, all that? Remember, in an exponential, the domain is what in an exponential? Are there any restrictions? No, we love our exponentials because they have no domain. They have range issues, but not domain issues. So that's it. Victory. 3 is ours. All right, don't lose those notes. We still got stuff to do, and if we have time, we might do a little bit of extra, some of that extra stuff in there. But I want to get this review material out to you. Okay.
Oh, wait, yeah.
Your exam review.
You already started.
Organize. Topics. Okay, so what I did was, took every, Miss Grieve actually typed this up with the lines in there, and then I filled in all the stuff. So 1.1 behavior functions, so I've got 6 questions in there. And you just kind of, if you pay attention, you can figure out what's going on. And then for rates of change, there are some questions in there, and so on, and so on, and so on. So what I want to do now is go back to, start with 2.9. We took a mini quiz, remember, over 2.7 and 2.8. So we're going to start with 2.9 today, and we're going to do some review. Now this is your exam review, but it will serve review for this stuff too, because we're going to have our mini quiz 2.9 to 2.13 on Wednesday. Okay, so we'll start reviewing today, we'll review some more tomorrow, and then we quiz on Wednesday. Got it? Okay, so I circled some things. I certainly want to, we have plenty of time probably to review it all, but I have a few that I really want to make sure we do in preparation for our mini quiz. So in 2.9, let's do some evaluating. On the quiz, there's actually a pretty good size chunk, I would say, 6 to 8 questions that are things like this. This is no calculator. You have to figure this out. They're not hard. I know you can do it. What's your thought when you look at this? So you want to set it equal to x? Now, that's okay, but if you're going to do that, there's absolutely no, it's not just okay, it's fine, it's wonderful. But you can't log roll until you take care of that. So he becomes an exponent on the 9. So this is log base 381 equals x. And now you can certainly log roll. So 3 to the x equals 81, so x equals 4. Yep. Not hard at all. Next one is negative log base 8 of 1/4. Now again, you can use exactly the same strategy, but don't do anything till you take care of that. So what happens to that? It becomes an exponent on the 1/4, which changes it into a 4. So 8 to some power is 4. 2 cubed to the x equals 2 squared. So 3x equals 2 and x equals 2/3. You're exactly right. ln cube root of e. Could be longer one. What's the base here?
Oh,
E. ln. ln, guys, is log base e. So this says e to the x equals the cube root of e. What power is cube root? 1/3. Remember, fractional exponents are radicals. Fractional exponents are radicals. And the last one there, log base 6 of 1. Zero. 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 Everybody okay? There's a whole bunch of those on one of the homework assignments, so if you need more practice, you can go back and do that. All right, number 3. Rewrite log base 6 of 12 as a natural logarithm. So what does that even mean? Natural logarithm. ln. So base e, right? This is a base 6. We want to rewrite it as a base e. You can always change from one base to another using that change of base formula, which says what? Log 12 over log 6 every time. And you can make that whatever base you want. So in this case, we want base e. So it'll be ln 12 over ln 6. You could make it base 10, it'd be log 12 over log 6, you could make it base 3, whatever base you want. This formula, log this over log this, any base you want. So there it is. This is now written as a natural logarithm. I want to add one in here that's, I don't see it on that sheet. I want to add it in. By the way, guys, do you have any idea how long it took me to put this thing together? It took forever. And then I sat down and did all the answers. They're going to be posted in Schoology. And that was a while too. And some are probably wrong, so let me know if I do find any mistakes in the answers. I want to do this. I want to write log base 6 of x as a vertical dilation of log base 4 of x. So again, that is a fancy hard way of doing this exact problem. So look at this right here. That will be log x over log 6, log x over log 6, any base you want. So let's use base 4. Are you with me? Now, this, which was log base 6 of x, written, now we change the base to 4, that's 1 over the log base 4 of 6 times the log base 4 of x. So it's this divided by this, so I wrote that as 1 over. This is a number, which we can figure out if we want, like 2.3 or something. So isn't this a vertical dilation now? We have multiplied our function by a number. And when you multiply it by a number, it's a vertical stretch or shrink. Anytime you want to change a logarithm into a different base, use this idea. Always. log that over log that, whatever base you need. Alright, 210. Alright, we need to just make sure that we are completely okay. So in 2.10, it says sketch f of x equals 3 to the x, and its inverse. What is the inverse of this? Log base 3 of x, that's exactly right. Okay? Now, we did the exponentials, actually that was back when we had a big quiz over all that. But you know what your exponential looks like? It looks like this, right? So what is the inverse going to look like? If you have to sketch this, the inverse is going to look like this. Did everybody agree with that? That is a logarithmic picture. Okay? So what about end behavior? Normally, when we talk about end behavior, this is the notation that we use. This is the notation you will be using primarily when you do end behavior on your exam, because you'll be looking at all kinds of different functions. But in a logarithmic situation, because of the domain issues that logarithms have, you don't do this. You do this one, but you don't do this one. What does this one have to be instead? This has to be 0 from the right. That's as far left as this picture goes. So a lot of times he puts left and right, going left, going right. Well, this is as far left as a logarithm is going to go, unless you've done flipping or something to it. Okay? So for this one, the limit as x approaches 0 from the left is negative infinity. And as x approaches infinity, it is positive infinity. Is everybody okay with that? This is important, this end behavior notation. All right, and then number 3, I'm still in 210. Number 3 says sketch this logarithm. Who remembers what's different when the base is less than 1? The base will always be positive, but what happens to our picture when the base is less than 1? Anybody remember? It's like a negative. It's reflected across the x-axis. That's exactly right. So instead of looking like this one, it looks like this one. So end behavior for this guy, again, 0 is as far left as it goes. And so what are our end behaviors this time? On the left side, it's positive infinity, and on the right side, it's negative infinity. All right. In 211, number 1, we've already described that. This was log base 3 of x. Will log base 4 of x be essentially any different? No, different points, but generally the same shape. Okay, 2, consider this. Okay, these two are not related. They're just two separate problems. And we're going to talk about whether they're increasing, decreasing, and they're additive. So, you guys, we've done enough of these, hopefully. you can sketch 2 to the x pretty quickly. What does 2 to the x look like? Airdrop for me. Yep, Emily, you got it. It's just like this. Perfect. If you have to make a more careful graph, you can always set up a T-chart and plot points, right? Always. But in this case, we just want to know, is it increasing or decreasing? Clearly it is increasing. Concave up or concave down? Clearly it is concave up, right? Which means what about its rate of change? It's increasing. Rate of change is increasing, which makes perfect sense because it's an exponential, guys. And what do exponentials do? Right? Yeah. Okay, now what about this guy? This is a logarithm. He's a regular logarithm, and I say regular, his base is bigger than 1. So it's a regular logarithm, but upside down. So doesn't he look like this then? Increasing or decreasing? Decreasing. Concave up or concave down? Concave up. Find the domain. All right, let's look at 212, number 3. ln 4x minus 3y is ln x to the 4th over y cubed. Y, is that true? Why or why not? What do you think? Why not, Riley?
Because the 4 and 3, they're not exponents.
Yes, you're right. It might be easier if we took apart this. What would this be if we took it apart? Wouldn't it be ln x to the 4th minus ln y cubed? So 4 ln x minus 3 ln y, that's what this equals. And that is certainly not the same as this. All right, 2 to 13, here we go. Oh, in 212, there's that question number 4, which we already talked about. Question number 4 we talked about already, but there it is. All right, number 1 in 213. No calculator, solve this equation. Glenn, quit writing on your pants. What's your thought? Now, Quinn says take the logarithm of both sides. Is that a legitimate option if you're, on a desert island, you gotta solve this equation? Can you log both sides? Yes. What does that require, however? A calculator. Unless you happen to know what the log of 4 and the log of 1/2 are, you're gonna need a calculator. So, if we don't have a calculator, this is a no calculator question. If we don't have a calculator, what do we need to do? Yes, sir. That's exactly what we need to do. Did you figure that out, or did he whisper it to you?
I figured that out.
I figured that out.
Get
Good
with
for
it.
you. So what would your base be, looking at these two numbers? What do you think? 2. So 4 is 2 squared. And what's 1/2?
2 to the negative first.
2 to the negative first. And as soon as you have the same base, then you can just solve your exponents. So 6x equals negative x minus 5. So 7x equals negative 5 and x equals negative 5/7. Is that okay? Everybody okay with that? Easy? How about number 6? Same sort of thing, but it's a logarithmic equation. How do we do this one? Yeah, these, you can't do this problem with these two logarithms here, so you gotta put them together. And as Oscar said, when I put them together, they're gonna go together as a multiplication because that's an addition. So that's gonna be, oh boy, these two times each other. So 2x squared plus 5x minus 12. And then what? And then we can cancel it out. So 2x squared plus 5x minus 12 equals 8x plus 2. 2x squared minus 3x minus 14. I think I've already done this problem once. I think this factors. If it didn't factor, I'd use the quadratic formula. And again, it's a logarithm. Check your domain. Check your domain. Can x be negative 2? No, because what would happen here if you put a negative 2 in, wouldn't this be negative 7? You cannot take the logarithm of a negative, so that is no good. What about 7/2? That's fine. 7/2 is fine. All right, let's do one more here. Find the inverse. Okay, this is just something brand new that we talked about today. So let's see if we can get this done. I'm going to switch my variables. So this is question 7. I've switched my variables. All right, now what? Add 10. Good. Divide by 5, either as a unit or individually. And because that's a 2 there, I'm going to use a base 2 logarithm. So the log base 2 of 1/5 x plus 2 simply equals y plus 4. So my inverse is the log base 2 of 1/5 x plus 2 minus 4. All right, well, we'll pick up here tomorrow. And if there's anything in particular you want to touch base on, like some homeworks or something, tomorrow would be the day to do